Welcome to the module on Inspection and Quality Assurance Program for cold asphalt recycling, and we're talking about the field operation. So we're talking about cold in place recycling, paving. My name's Trenton Clark and I'm with the Virginia Asphalt Association, and we'll walk through this, the roles of the inspector, as well as what it means to actually accept these products in the field. So what are our learning objectives? We want to make sure what your basic responsibilities are as an inspector. We want to make sure that as an inspector, that contractor is doing the longitudinal joints properly, that the contractor knows what the spec is, but you know as an inspector what you're looking for. We'll go through the specifications and inspection points for cold in place recycling and cold asphalt recycling placement. We're going to determine what those pay items are for the placement of either the cold in place as we're going through the process or as we're bringing out cold recycled material to the project. How do we accept it? How do we pay for it? And then we'll briefly talk about the components of a quality assurance program. So as an inspector, what are the things that you're really paying attention to that you need to be watching for? You need to make sure that pavement's being prepared properly. Really depends, are we talking cold in place? Are we talking about cold plant recycling? What really plays into what it means to be prepared properly? So we're going out, we're doing cold in place. Are we milling first before we do cold in place? Are we doing cold in place of all the material? Just need to understand what's going on there. If we're doing cold plant recycle, so we're doing it from an asphalt CCPR plant, we're bringing it out. Is the base that we're laying it on, has it been compacted? Is it proper? So if it's a new construction job and we're laying it on an aggregate layer or a cement stabilized layer or a subgrade layer, is that all correct? So the nuances of what the project really requires really determines, is that existing pavement properly prepared? We'll make sure all the right equipment's being used, and that's really laid out in these specifications and special provisions. We'll go through that. If we're getting new material delivered to the site, is it within spec? Well, what does that mean? If it's cold in place, we've got stabilizing agents. Is the stabilizing agents, whether it's the foamed asphalt or the emulsified asphalt, is it the correct material? If we're having to add some aggregate on a cold in place, is that the right aggregate? Are we checking it? If we're back at the plant, we'll cover that in the plant class, but we're making sure that if we're making the material through millings, is that proper? We're going through, we're making sure that the stabilization is done right in the cold in place process. We've got the proper construction sequence and all the activities are being performed. And last but not least, making sure that QA program is actually being executed. So what is a construction inspection in all this process? Well, if you're an inspector, you're representing VDOT or the owner. So that could be a consultant employee, it could be a VDOT employee, but you're representing the owner and you're making sure that the spec book's being followed as well as any special provisions, anything that's in that contract document is being performed properly. VDOT's field reps and the contractor, though, both play a role in the QA program, and we'll touch on that later in this module. So before we get started, it's really good to understand the specs is by digging into the specs. And one of the best ways of digging into the specs is just doing a little practice. So we've got a few questions. Let's see if you can find the answers to these questions. What materials are commonly utilized as a stabilizing agent for cold in place recycling? What's the maximum particle size allowed once pulverization has been completed for CIR? The contractor's technical representative at the project site shall have how many years of experience? What materials can we be using for a fog seal? And how is CIR specified and paid for on a project? So take a few minutes. In your student guides and your study guides, you have the special provision for cold in place recycling. Let's take a few minutes, answer these 5 questions, and then we'll go over the answers. All right, so let's look at that first question. What materials are we commonly utilizing? Well, if you look in Section 2 materials of that special provision, you'll see we're using foamed asphalt or emulsified asphalt. Foamed asphalt is a neat asphalt binder, so it's a non-modified asphalt binder that is combined with a little bit of water, causes it to foam, expand, covers the particles, and then we compact it back together. We have an asphalt emulsion, which is water and liquid asphalt mixed in proper proportions with some other modifiers that again is used, injected into the material, into the housing of the cold in place recycler, and again that's used to coat, and then that becomes the binding agent to stabilize that layer. So 2 different materials are called for in that section. What's the maximum particle size? So we've gone through, we've pulverized it with that cold in place recycler. We find in section 4, job mix formula table 3, 1.5 inches. So as we've gone through, and remember in module 1 I said this is very similar, or it can be the same as a milling type of equipment. So as you've gone through and you've pulverized, all those asphalt and aggregate particles should all be less than 1.5 inches in size. And that can be checked by dry sieving, and we'll talk about that later. A few other questions. A contractor's technical rep. How many years of experience? Well, if we look in section 6, trial section, we find it's a minimum of 2 years of experience. This person may be called upon if our first trial section fails, we're not able to get density. VDOT may say, please bring out a technical rep, and whoever the company brings out, whether it's a person that works for that company, maybe it's a manufacturer rep, maybe it's an outside consultant, they need to have 2 years of experience to be on site to meet that requirement. What materials can be used for a fog seal? Section 7.5, construction methods, we see it's a CSS1H or CQS1H, and it's got to be per section 210 of the spec book. So early in that special provision, it says these materials in section 2.6 are to be used. Everything goes back to that original spec book that says what a CSS1H is and a CQS1H is. And last but not least, how do we specify and pay for it on a project? We look at section 10, measurement and payment. It's by the depth in inches, so the contractor will say go down 4 inches, 5 inches, 3 inches. And then once that depth is met, payment's based on square yards. So we actually estimate the square yards in the contract documents, but we measure the actual square yards for payment purposes. And this is in section 10, which if you look at most specifications and special provisions, the very end of those documents is where we talk about measurement and payment. So if you ever have a question, if something's paid for and how it's to be paid for, flip to the end. So that was cold in place. Let's do the same with the cold plant recycle. So the material that we're making and bringing out to site, what are the weather restrictions? Are there weather restrictions for paving this material? How long after fog sealing and gridding can traffic be allowed on the CCPR? What's the standard size of a lot? So we pay for materials in lots. What's the standard size? During the depth check of a CCPR layer that is 5 inches thick, so we're doing this in a 5-inch thick lift, 3 tests are performed. What's the tolerance on the thickness? Take a few minutes, answer those questions, and then we'll come back. Again, in your books, you have the CCPR special provision where you can look to find the answers to those questions. All right, so let's go through those questions and see if we can find the answers. Let's talk about weather restrictions. If we look in section 4, weather limitations, minimum of 50 degrees for air and material temperature, no freezing temps predicted for 48 hours. So that material needs to have heat in it, 50 degrees, and the air around it, because the air will suck any heat out of that material. So it's got to be warm air in warm material, and we don't want any freezing within 48 hours, particularly if we're trying to add a little moisture for compaction aid. We don't want to add moisture, not have it evaporate, get a freeze. When water freezes, it expands and it can break those bonds. So you're looking at the weather forecast, and if you're down around 50, you want to make sure you don't have any overnight lows less than freezing. How long after fog sealing and gridding can traffic be allowed? Look in section 5, placing and finishing, subsection 3, 2 hours. So after 2 hours, if we've fog sealed and gridded, we can let traffic on it. What's the standard size of a lot? Well, now if we look in section 6 under acceptance, and now we look in under subsection 2 test section, we see it's 5,000 linear feet. So if you're familiar with asphalt paving, same type of approach. Standard lot size is 5,000 linear feet. We're doing a depth check. It's 5 inches, 3 tests. If we look under section 6 acceptance, 3 depth check, in table 2, we'll find that you have to have a 1/2 inch. So if we've called for a 5-inch thick and we've done 3 tests, the average of those 3 tests have to be plus or minus a 1/2 inch. So it can be from 4.5 to 5.5 inches thick to be acceptable. So in module 1, we showed you this diagram. Just as a refresher, most of these projects will have special provision copy notes and special provisions. They may include plans, especially if you're using CCPR, because we may be using it as part of a construction project. But as you're looking at these, just remember, copy notes have the highest level of authority in this hierarchy. Standard drawings have the lowest. So as you open up your contract documents and read through them, see what special provisions and copy notes exist, what special provisions, are there any notes on the plans? Because there can be some notes in here that, again, carry more weight. So be very familiar, and it's very much recommended during your pre-construction conference you talk about these things to make sure everybody's on the same page. So here's a picture. We're doing cold-in-place recycling out on Interstate 81 several years ago, and you can see here's the equipment that we're using. We'll talk about that for the CIR. We'll talk about trial sections. We'll talk about construction methods. We'll talk about acceptance testing, and then we'll finish with weather. So here we are. We're going to do some cold-in-place recycling because, again, here we're out on an existing project. We're taking that material that's in place, and we're going to actually pulverize it in place and pave it in place. So are we putting some type of cement, polizonic type material to aid in the overall process? If so, we need to make sure it's uniformly applied. Sometimes we need to add that little bit of cement to give us some fines, especially if we're doing like a foaming type process to, again, aid in the distribution of the foamed asphalt, to aid in initial strength gain, but to allow us to actually do the process and get that final product that was specified. And are we at the right application rate? That'll all be determined during the mix design process. So once you get out in the field, you're ensuring that it's being followed. So you can see here's a truck, maybe it's spraying. Here's some cement that's been added. Here you can see the tracks of the reclaimer coming through, or the cold-in-place recycling unit coming through. And it'll mix this cement. Maybe it's a lime kiln dust. Maybe it's, depending on what it is from the mix design, will be mixed into that pulverized material along with the ultimate stabilizing agent, which is either foamed asphalt or emulsified asphalt. Some other things we look for on that cold-in-place recycler: are we using a screed? Is the screed attached to it? Or are we coming back through with a separate paver? If so, how's the material being moved into that paver? If it's without a screed, the paver's got to comply with 31503B of the Road and Bridge Specifications, the 2016 spec book. It also has to have an MTV, or a material transfer vehicle, to pick it up and to drop it in, so it could be a windrow device. Automatically adjusting water for slurry and other stabilizing agents. So depending on how we're stabilizing, along with the materials that we're adding, we got to make sure that we can adjust it all properly. Any additives have to be within plus or minus 0.2% of the job mix formula. And we can add up to 5% of water by weight with the pulverized. Now water is being added to aid in the compaction process as it comes out from behind the paver screed. So we've talked about the distributor, the recycler, the rollers. So now that reclaimer's gone through, it's cutting to depth, it's mixing. As we come behind it, rollers have to be within section 315.03C of the spec book. We need one pneumatic roller at 50,000 pounds, and we need one double drum roller at 24,000 pounds and 78-inch wide drum. So those are required per the special provision for cold in place recycling, cold plant recycling placement. So let's talk about the trial section. So as we get going, we're trying to replicate what full production looks like. We want to make sure all the equipment that's necessary is there and all the testing and acceptance personnel are there. So we want to do a short section compared to the overall project to make sure everything's in place. And we can find this both in the cold in place recycling special provision and the cold central plant, depending on what it's at, the different pages. But again, what we're doing is making sure, can we get compaction? So looking at the equipment, looking at the personnel, what design are we doing? What depth are we doing? So if we're putting down 4 inches of cold in place, are we cutting 4 inches? And then we're going through the process. If we're doing CCPR and we have a lift of 5 inches, are we putting down 5 inches? We're going through the whole process. If we're doing CIR from beginning to end, are we getting compaction? If we're doing CCPR, are we going through the process, putting it through the paver, compacting it, and getting density at the end? So that trial section, again, is making sure that we can walk through, just like we do with asphalt, before we go to full production. So let's talk some specific inspection points for when we're doing a trial section with CCPR. One, we're doing it a week to no more than 30 days before we plan on going to full production, because we want to make sure that the entire process and the materials themselves all pass spec. We're doing a minimum of 1,000 feet. So this is bringing material out in dump trucks. We're putting it in a paver. We're paving it. We're compacting it. So we want to go 1,000 feet or so, 1 lane wide, to make sure we get compaction. We're checking that contract depth. So if we're calling for 5 inches, is the compacted layer thickness 5 inches? We're going to consider it as a lot, just like we do with traditional asphalt, conventional asphalt materials, whatever that trial section is, it's a lot. The density that we get will be considered for payment. And what's important is if we should fail that trial section, the department can require the contractor to bring out a technical rep to be at the plant and its site. Do we have a plan issue? Maybe we need to be watching that. Do we have a construction process issue? Bring them out on site. But if we have failing, the department can say, hey, get a tech rep. A little bit different with cold in place. Same type of thing. We're doing it before we go to full production. We're going a little bit further now. Instead of 1,000 feet, we're going 2,500. So we're going about a half a mile. We're checking the depth. So if we called for 5 inches of cold in place, are we cutting down to 5 inches as it's called for and compacting it back? Making sure that those stabilizing agents, whether it's foamed asphalt or emulsified asphalt, is being injected properly. Just with cold plant recycle is considered a lot. So if we go 2,500 feet, then the density that we get on that's how we determine payment for that material. And the same thing with the cold plant. If we have a problem during the trial section, VDOT can say, hey, bring out a technical rep to make sure that we get this right before we do another trial section. So what are some things we need to look at? Well, let's look at the cold in place process. Again, We're looking at that special provision. Want to make sure that we don't have any grass or vegetation being pulled in, because again, we're going this right over to the shoulder of the pavement. So we want to make sure that we're not getting over too far and pulling in grass. With the code in place, we're checking milling depth, 4 inches, 5 inches, 3 inches, whatever set up on the contract. We're checking particle size. So remember, when that pulverization goes through, we're going to do a dry sieve, make sure nothing's greater than 1.5 inches. And if there's paving fabric encountered, we're getting that removed. Ideally, this is checked even before we set the project up, so we're aware, is there any paving fabric out there and is it causing any problems in the overall CIR process? Here you can see, here we're going down the road. This is coming out from behind, so here is our milling head is up here. Here you can see the existing underlying pavement. You can actually measure that depth. To check gradation, we could have this section without it being stabilized, pull it out and do a dry sieve, but we can do the depth check right over here quickly with a ruler. Are we cutting down to the depth that's specified in that contract? And here you can see the materials coming out. There is a screed attached to that milling or that cold in place recycler. Materials being spread out, and it's actually being placed right behind it for compaction. We're looking for big pieces. You know, here we can see I pulled a rock out of it that wasn't expected, so we are checking particle. Overall though, is it within spec? So it's less than 1.5 inches. We're checking the longitudinal joints. Are we having overlap? Because we don't want to miss any area. Requires 4 inch per spaces, but we don't want to over stabilize the materials in the overlap. So if we have to make 2 passes to get a lane width, and we have a longitudinal joint, because we have to make 2 passes, that area we have to make sure that we're cutting off the nozzles that are adding either the foamed binder or the emulsion, so we're not doubling that same area. So if we had a 1 foot overlap because of the width of the milling drum on the cold in place, that 1 foot doesn't get treated first. So we may treat it the first time through, and then the next pass adjacent to it, that 1 foot, we're not adding more stabilizing agent. With transverse joints, and it's the same day, we back up 2 feet, start off again. Again, we're not trying to add a lot more material. From one day to the next, we're going about 50 feet and restabilizing, because we want to have a good transition from one day's production to the next. We've talked about longitudinal joints, transverse joints. Let's talk about compaction. By spec, the breakdown and intermediate is done with a pneumatic tire roller. So if you look in the special provision, it calls for a pneumatic tire, because that helps knead and put that material together. Finish rolling is done with a steel drum to make it a nice, smooth, uniform surface. We have to start our breakdown compaction within 30 minutes of paving. So once that cold in place has gone down the road, coming out from behind that screed within 30 minutes, we don't want to allow this material to dry out where we're not able to get density and compaction. So it's got to start within 30 minutes. We need to be done within an hour. So that means you have to have the right equipment, enough people to make sure that before time we start, time we finish, within an hour. So again, it's critical that we've got that organized, and that's what helps with doing the trial section. Compaction to fog sealing and gritting, we have application rate of 0.06 gallons per square yard or 0.04 gallons per square yard residual. So we're going to put a fog seal, going to use CSS1H or CQS1H as the material, and we're not going to allow any traffic on that recycled material until 50% optimum water content. Because what will happen is it'll damage the surface, it may damage the overall layer, so we want to make sure that the water's had time to evaporate, we've got the compaction in place before we open it up to traffic. Surfacing itself is, one, we're not going to do it until the moisture's. So we don't allow traffic on it until it's at 50%, but we also don't pave it. And that paving Could be either with a with a asphalt layer, a surface treatment layer, or a slurry surfacing layer. But to ensure that the moisture is right, we follow AASHTO T329. We pick a couple random locations, we grab material, seal it, and then we take it back, following the procedure to check what is the moisture content. Is it at 50% or less of optimum? We see that in the cold in place recycling special provision, page 7. So now let's go on to how do we check the field compaction? Because just like asphalt materials and other materials, we're trying to get compaction. We want the density, so how do we do it? Field compaction, we're using a nuclear gauge. So that's how we're checking it. We're doing a VTM 10 with a single sample for moisture content to do a moisture correction, because what the nuclear gauge is reading is the amount of hydrocarbons. So you need to know how much moisture is in that sample to correct the nuclear gauge to make sure it's reading correctly. Compacted thickness, if we're 3 inches or less, we're using the backscatter mode on that nuclear gauge. If we're more than 3 inches, we're using direct transmission. So we're driving a pin and then we're inserting the rod from the gauge down into that layer to check what the compaction or what the density is. It's got to be calibrated within the last 12 months. So again, we want to make sure this gauge has been working, it's been checked. We're following VTM 76 for marking density testing locations. So you have VTM 76 in your package that talks about how that is done. We follow VTM for the testing itself. We're going to do a field proctor from AASHTO T180 Method D, because we want to check that material in the field with a proctor to see what is it compared to what was mixed design, compared to what we're actually getting in the field to make any adjustments. And then minimum of 98% density of the target from the approved job mix formula for nuclear density and field proctor. Again, going through the entire process, we want to make sure that the density we're getting in the field is what we're expecting going back to our approved job mix formula. Well, let's talk about the lots. So what do our lots tell us? Just like our asphalt paving, we're using stratified random sections and locations of the test sites. So we're not going all the way to every time to 50 feet into a lot or 300 feet. It can be randomly selected. We're doing 2 tests per sublot. So if you're familiar with asphalt paving, every 1,000 feet, we're doing 2 random tests within that 1,000 feet. There's typically 5 sublots or a lot, so a standard lot is 5,000 feet in length. It can be adjusted at the direction of the engineer. Get that in writing so you have it with your paperwork. Just like traditional conventional asphalt base mix, we don't do any testing within 18 inches of the longitudinal joint. I'm not talking about where we're doing cold in place where we may have an overlap within the mat, within the lane, but we're talking the edges. So the left and the right. So we're staying 18 inches. In the middle of that map where we may have an overlap due to the equipment being used, that can be tested. That's part of the randomness. Start a new lot at the beginning of each production shift. Monday's a new lot, Tuesday's a new lot, Wednesday, or when you exceed the lot length. We're verifying with a field proctor, are we getting the density? Are we meeting that minimum target density from the job mix property for the maximum dry density? So we're going through the whole process to ensure through a field proctor, are we getting that maximum dry density? And very importantly, payments per table 5. So in that special provision, what is the percentage of our control strip density? So we were able to achieve X pounds per cubic foot. Are we 98% or greater of that? So to make math easy, if your control strip that passed was 100, you got to be at 98 or higher to get 100% pay. If you're at 97 to 98 pounds per cubic foot, you're at 95, and if you're less than 96%, or if your target's 100 and you're less than 96 pounds, you're at 75% pay. So again, as you go through the process and you do that trial section, our control strip, what density were we able to achieve? Does it pass? And then when we go to set the actual roller pattern control strip, when we go to full production, are we able to achieve it? Some other things, if I get 2 failing sublots that fail, so we've got 5 sublots and sublot 2 and sublot 3 failed, need to stop, take immediate action, notify the engineer, because you don't want to continue failing sublots. And you got to give all data back over to the engineer for their records purposes and for payment purposes. Some other things with code in place, we got to check the gradation, because again, this process is done in the field. So we have a mixed design that we're following, but in the field we got to ensure that mixed design is being hit. So we're doing gradations on that unstabilized material. If you recall a few slides back where I showed the material coming out from behind the code in place recycler prior to the screed, you do that unstabilized for a distance, you pull it out, you do a dry density to make sure you don't have anything greater than 1.5 inches, that it's within your gradation bands that you were expecting. We're performing that gradation at the beginning of the day's production. We don't want to go 4 hours into it. We're doing it early on in that production to ensure that the gradations are being met. We're doing additional gradation checks when you see something change. Pavements aren't homogeneous from beginning to end. There may be a small patch, which isn't a big concern, but you could get into completely different pavement structures. If you've done the work up front through coring and other methods, you should know where those pavement breaks are at and those changes. Through this process, you'll see those changes also as you're going through. And when you see those changes, it could be you have another mixed design, but you also need to do another gradation check. And if the gradation fails, you got to take some immediate corrective action. What does that really mean in terms of code in place recycling? Could be you have to change your milling speed or your recycling speed because you have that drum turning in that housing, and maybe your material is getting a little bigger, a little larger. You may have to slow down or change something with that milling head speed to reduce the size back down to the 1.5 inch max. We talked about gradation. Now let's talk about depth checks. Depth checks, we're doing it twice per 1,000 feet after final compaction prior to surfacing. So are we getting back to the thickness that we needed to be? We called for a cut depth, but what's that final thickness? Keep in mind this material does fluff up. That needs to be taken into account when you're going through the overall process, putting together the contracts. That needs to be considered because you're adding some volume, you're adding some air that wasn't in that original compacted. Just as the nature of the process. We're going to follow VTM 38 Method B. So when we go out and we actually check it, do we have the depths that we're calling for within the tolerances? Table 6 of the special revision does have those tolerances based on the number of tests that you're taking. Remember, we're not paying for excess material, basically a stabilizing agent, because the pavement's already there. The asphalt that's being recycled is already in place, but they're not going to pay that if you add additional foamed asphalt or if you add additional emulsified asphalt because your depth was too much. If your depth isn't enough or it's deficient, then the contractor has to make up for it to get you back to that planned depth. So here's table 6. You notice we talked 4 inches or less. If you remember that we talked about module 1, 3 to 4 or 3 to 6 inches is our typical thickness for a code in place. So 3 to 4 inches, whether we're doing 2 tests, 3 tests, or 4 tests. If we're 4 to 6 and 6 is the match, again, the tolerance gets tighter the more tests you take, so you're averaging 4 measurements or 3 measurements or 2 measurements. Lastly, let's talk about dosage rates. Contractors verifying the dosage rates 10 times per lot. So you're going and you're looking for that stabilizing agent and you're recording down how much foam binder is being added, how much emulsified asphalt. What's being added needs to be within 0.2% of the job mix. So if it calls for 2.9%, 3.1%, are you plus or minus 0.2 of it? And if not, you're outside, you need to stop and take corrective actions. Maybe something's gotten off calibration. Maybe there's a problem with the feed coming in from the nurse truck. Whatever it may be, once you catch it, you need to stop, take corrective actions before you proceed down the road. Construction records, so you've done all your inspection. Your construction records are either following AASHTO R18 or you're completing VDOT forms. You're recording dosage rates in the table 4 results, and you're providing it all to the engineer. So the contractor's doing a lot of these things, the inspector's doing a lot of these things, all the material gets turned over to the engineer at the end of the day. So let's change gears real quick. We've talked about cold in place recycling for a little bit. Let's go back to cold plant recycle. Think of it again, it's very similar to asphalt. Base mix is coming out to a project. We follow a lot of the same steps, but what's slightly different is because of the nature of the product, the nature of the material. We're not doing moisture corrections with base asphalt, but we are with cold plant recycled, the CCPR that's coming out. We're still using a nuclear gauge. We're still following VTM. We're doing moisture correction. Compacted thickness, we can do backscatter or direct transmission depending on the lift thickness. We need to make sure it's calibrated. And the control strip, VTM 76, VTM 10, a field proctor to see exactly what we're getting, because some of these products may have some distance that it's traveling. So what's at the plant, by the time it gets to the field, may have changed a bit the moisture contents because we have evaporation. And again, we're looking at 98% density of target from approved job mix design for nuclear density and field proctor. As you can see, there's nothing really different between this and the cold in place recycling. It's very similar. The lot sizes, when we look at them, again, very similar. If you look in the cold plant recycling special provision for the placement of this material, what's different is this table 1. And the only thing that's different is what we're referencing. Remember in the cold in place recycling, it was table 5. Here's table 1 in this special provision, but it's the same target. It's 98% of the control strip for 100% pay, 97 to 98 for 95. So whether you're doing cold in place recycling or cold plant recycling material and bringing it out, the density that we're shooting for is the same. Same thing happens if we end up and we got 2 sublots that are failing consecutively. We need to stop and take corrective action. Is there a problem going on back to the plant? So we're calling back to the plant, something happened to the material. Did the moistures go off? Did we have a problem with actually mixing? Or did something happen in the field as we go through the compaction process? What changed? Maybe it's what we were compacting it on changed. Maybe it's a little softer. Maybe it's a little something altered. Maybe the equipment. But again, you need to stop and figure out what it is, because we don't want to continue to pave. It may mean everything's perfectly fine, but what we're paving on changed. At that point, we need to stop, set up a new control strip, get a new target, and continue on. But before you do those things and make that decision, stop, talk to your engineer, implement some corrective action, try to determine what is the cause of that failure, and continue on. And provide all that data to the engineer at the end of the day for acceptance and payment purposes. Depth checks, a little bit different than cold in place, more similar to what you see with base asphalt, just because we're not doing it in place where we're checking not only initial cut depth, but we're checking compacted thickness at the end, twice per 1,000 feet, no change from cold in place, still following VTM 38 Method B. No change. Table 2 now contains those tolerances. We'll show that in a moment. How we pay for excess material as well as deficient material, really no different. So here's table 2. What is different from cold in place is, notice We have less than 4 and 4 to 6, same as cold in place. But for the cold plant, we can also go deeper. So if we're doing multiple lifts, maybe we're doing 2 6-inch lifts. It's part of a new pavement structure. And then we want to do the full depth. What are the tolerances by the number of tests? And this is very similar to what you see on traditional asphalt paving. But again, overall, it's the same type of approach. When we're done, we're compacted, and we come back and we do depth checks. How do we go about doing it, and what is acceptable? What's within specification, what's outside of spec? So look at our inspection points, talk to field compaction, lots, depth checks. Finally, our construction records. We're either filling out stuff with our AASHTO R18 or the appropriate VDOT forms as we go through. So are we filling out the density forms, what have you, the depth checks. Talk weather. Whether it's cold in place or cold plant recycle, it doesn't matter. The weather limitations are the same. Recycling is completed when the air and the material temps are 50 degrees minimum. So we're looking at 50 degrees and higher. We're not doing this in the 40s. We're not doing this in the 30s. We have found through experience it does not work well. So that 50 degrees is in the spec for a reason. And we don't want any freezing temperatures forecast. Reason being, both whether it's cold in place or cold plant, we're injecting an amount of water. If that water hasn't evaporated before it freezes, water freezes, it expands, and it can break down the bonds. Let's talk about the QA program. QA is quality assurance. It's the overall program that the department follows in conjunction with the contractor to make sure that the product and the process and everything conforms. Quality controls performed by the contractor is to monitor their processes, monitor their procedures. Are they making the material properly? Are they compacting it properly? Are they doing all the things to ensure the final product is met? Acceptance testing, depending on what it is either done by the contractor or the owner. In this case, the contractor is doing the acceptance testing, so they're going out, they're doing the density testing. VDOT or their rep is overseeing it, but the actual acceptance testing for density is done by the contractor. So they do the acceptance testing. We talk about independent assurance. What is that? Well, that is VDOT or their rep coming out and making sure that the acceptance process is being performed properly, but it doesn't mean does the material pass or fail. So they're watching, making sure that the person doing it, one, is certified. Are they doing it properly? Are they following the right processes and the right procedures? And is the equipment, is that nuclear gauge calibrated? Are they following the AASHTO spec, the field proctor's spec properly, the process? They're not saying does the material meet or not. They're just making sure the person doing the acceptance testing and all that they're doing is correct. To check to see if it's actually meeting spec, the department or their rep can come back out, do verification, sampling, and testing. So completely independent of the acceptance process, they're verifying to say, if I did a test, do I get pass or fail? So how could you do this on cold plant recycler or cold in place? Since we're using nuclear gauge, well, one of the things that they can come out, they can put their own, drive their own pins, do their own testing, do any moisture corrections, and see if I follow these, do I get within the same results? If contractor says I got 99%, does department get approximately 99%? What we're trying to find is if contractor says I'm at 100%, VDOT finds that they're at 95%, why do we have a difference? At this point, we don't have a very formal process as we're new into the whole cold recycling. So over time, this overall process will become more defined. What is the contractor doing as part of their QC and acceptance? Many times it's one and the same during their process. Cold in place, they're doing depth checks, gradation checks, density checks, moisture checks, stabilization checks. All these things are being done continuously. Some of it's required for acceptance and payment. The others are just to make sure the process is going well. During the cold plant recycle, they're doing depth checks and density checks. So am I getting the right thickness and am I getting density? So that density is the payment, but these other things also go into it. The independent assurance, again, we're just making sure everything is working properly in the acceptance. There right now in the manual of instructions is no documented VDOT procedure. That'll be under development, but we're comparing VDOT and contractor results if we do a split to see if we get the same comparable results. We're not saying it's a pass or fail, but if we took a split sample and VDOT got a result, contractor got a result, are they comparable? For the verification, sampling, and testing, again, it's not documented. It hasn't been completely vetted out and completed. But again, we're just making sure that if VDOT does density testing, independent of the contractor at a different location, do they get similar results? Do they both show passing density? So the verification, sampling, and testing is a way of saying, does it pass, does it fail, compared back to spec. So to summarize this whole process of inspection and quality assurance, you need to know the contract and the related specs and the special provisions and any copied notes. You need to know those 4 primary areas of inspection as an inspector. What are the things that you're looking for? It varies between cold in place and cold plant recycling, but at the end of the project, is the depth right and is the density achieved? So you want to make sure that when corrective actions are needed. So do we have a problem with the dosage of the stabilizing agent? Do we have problems with density between 2 consecutive sublots? Know when they should be taking corrective action. And make sure you collect all the required testing data for acceptance and payment purposes for your project documents. With that, if you have any questions, please feel free to reach out to your moderator, your facilitator, and good luck.